Hey there, welcome back to Turtle Maths. Today we are diving into a world of mathematics to demystify a topic that is often seen as a puzzle, solving quadratic equations using completing the square. This video is part of the quadratic equation series that I have created. If you haven't watched the previous video, please do watch them. I have deliberately spoken slowly in this video, so please feel free to watch it at 1.5x if you want to just revise. There are plenty of examples followed by some IGCSE Further Pure exam questions as well. So don't worry, by the end of this video you will be a pro. So grab your pens and notebooks. It's time to crunch some numbers. Completing the square means that we would like to write any quadratic which can be written as y is equal to ax square plus bx plus c. We would like to write it as y is equal to ax minus h whole square plus k. Now, writing like this is also known as writing it in the vertex form. And the process of writing any general quadratic into this form, the vertex form, is known as, this method is known as completing the square. Example 1. Write y is equal to x square plus 6x minus 4 in the form y is equal to ax minus h whole square plus k, and hence solve it. So there are two parts in this question. Part 1, writing the given equation into vertex form using completing the square. So let's just start with our part 1. Any quadratic can be written as y is equal to ax square plus bx plus c. Please notice here my a is equal to 1, my b is equal to 6, and my c is equal to negative 4. Now in this function Ra is equal to 1, which makes things easier. In the next example we will also see how we can solve or how we can convert a quadratic where a is not equal to 1 into the vertex form. Now the step 1, to write the given function into vertex form, we will halve the b, which means we will halve this 6. We will halve this b, and we will add and subtract its square from the given function. So let's calculate what is our b over 2. So it is 6 over 2, which is 3. I have to add its square as well as subtract its square from the function. Now adding 3 square and subtracting 3 square has no effect on the given function because I am adding the same quantity and I am subtracting it. So it will actually nullify each other. But when I write it like this becomes, I can rewrite it as x plus 3 whole square. And now you have minus 3 square is minus 9 minus 4, which will give you y is equal to x plus 3 whole square minus 13. Now this is very interesting because once you have written it in the vertex form, our part 1 is done. We have done this part. The second part is solving it. So part 2, solving it. Now solving quadratic equation means finding the x-intercepts, and to do so we will equate our function to 0. So our function, which is x plus 3 whole square minus 13, I will equate it to 0. Now we can add 13 to both sides, so we'll get x plus 3 whole square minus 13, and plus 13 will give us 0. And here I have added 13 to the other side, so 0 plus 13 is 13. So I am adding 13 to both sides, and that's what I have got. I will take the square root of both sides. And when I will take the square root, I will have x plus 3 is equal to plus minus root under 13. And the next step, why plus minus? Because I have got x plus 3 square is equal to 13. There are two possibilities. X plus 3 can be positive root under 13 or it can be negative root under 13. The next step, x is equal to minus 3 plus minus root under 13. I have subtracted 3 from both sides. So plus and minus 3 will give us 0. So I will be left with x, and then I will have minus 3 plus minus root 13. So my two solutions are x1 is equal to minus 3 minus root 13, and x2, or the second intercept, is minus 3 plus root under 13. Let's move to the next example. Example 2. Write y is equal to 3x square plus 12x minus 24 in the form y is equal to ax minus h whole square plus k, and hence solve it. In this particular example, you can see your a is not equal to 1. Here my a is 3, my b is 12, and my c is negative 24. So when my a is not equal to 1, I have to make it 1. And how I can do it? So let's see. Let's just start with our part 1, where we are going to write it in the vertex form. So we will write it as y equal to, take out 3 outside. So you will have 3x square plus 4x from a and b. We will factorize a and b, and we will leave c as it is, which is minus 24. Then you can apply completing the square. In the previous example, I have told you that in order to write things in completing the square, you have to half your b and you have to add and subtract its square. So if you will, what I will do 4 over 2 square, I have added it, and I will also subtract it, 4 over 2 whole square minus 24. Y is equal to, so this quantity over here is x plus 2 whole square. Let me erase this. Here we will get, so I can rewrite this thing as, it implies that y equal to 3 times x plus 2 whole square, and here 4 over 2 is 2, 2 square is 4, so minus 4 minus 24. Now I can expand this bracket, so y is equal to 3 times x plus 2 whole square minus 12 minus 24. It implies that y is equal to 3x plus 2 whole square minus 36. So our part 1 is done. We are able to write it in the form of y is equal to ax minus h whole square plus k. Here my h is negative 2 and my k is negative 36. Note, because I want to write it as x minus h whole square, so minus of minus 2 will give me positive 2, and k I will write as it is. So part 1 done. Let's do the most rewarding part, which is part 2, solving this. So as I have said earlier, solving a quadratic means finding the x-intercept of the quadratic function, and in order to do so, we will equate our quadratic function to 0. So here I have got 3x plus 2 square minus 36. Let's equate it to 0. We will add 36 to both sides, which will give us 3x plus 2 square is equal to 36. I can divide both sides by 3, which will give me x plus 2 square is equal to 12. And then we can take a square root. Whenever you will take a square root, one of the most common mistakes students do, that they miss writing this plus and minus. And the next step, I will subtract 2 from both sides. So x is equal to negative 2 plus minus root under 12. And hence my two roots, or two solutions, or two x-intercepts are x1 is equal to minus 2 minus root under 12, or x2 is equal to minus 2 plus root under 12. I will also take it forward and I will try to plot the graph. If you'll plot the graph of your function, since your a is positive, you will have a concave up parabola, and this parabola will intersect at x1 and x2. The values of x1 and x2 are given to you, and this h comma k, which is minus 2 and minus 36, is the coordinate of the vertex, which is negative 2 and negative 36. Let's see how we can do a more complicated problem, and that's what we are going to do in example 3. Example 3, y is equal to x square minus 12x plus 12. We are supposed to write it in the form y is equal to ax minus h whole square plus k, and hence solve it. You can pause this video and try attempting this question by yourself, since we have already done 2 examples.
Time up.
So part 1, which is writing it in the vertex form. So we will start with, here my a is equal to 1, my b is equal to negative 12, and my c is equal to 12. So let's see. We'll start with halving our b and adding and subtracting its square from the quadratic function. So I will have x square minus 12x. I will add minus 12 over 2 square, and I will also subtract minus 12 over 2 square from our given quadratic function. We'll have y is equal to x square minus 12x, and minus 12 over 2 is negative 6. Negative 6 square is positive 36. Again, I have a minus sign, and negative 6 square would be 36, but since we have a negative sign outside, it would be negative 36 plus 12. Now this thing over here is y is equal to x minus 6 whole square, and minus 36 plus 12 is negative 24. So y is equal to x minus 6 whole square minus 24. This is our vertex form. Part 2, solving it. Part 2. So in order to solve it, I will equate my given function to 0, which is x minus 6 whole square minus 24 equal to 0. It implies that x minus 6 whole square is equal to 24. We'll take the square root. So plus, I'll be left with plus minus root 24. Oops, I'm making quite a few mistakes. We'll have plus and minus root under 24, and then x is equal to 6 plus minus root under 24. So my two roots are 6. My root 1 would be, x1 would be 6 minus root under 24, or x2 would be 6 plus root under 24. These are my y-intercepts. It's a concave up parabola. It will intersect at these points x1 and x2. And since you know the vertex form, your h comma k are, your h is 6 and your k is negative 24. So the vertex coordinates are 6 comma negative 24. All right. Now let's see example 4, which is one of the more complicated problem. Let's see how we can solve it. Example 4, write y is equal to 8x square minus 96x plus 279 in the form of y is equal to a x minus h whole square plus k, and hence solve it. This is probably one of the more challenging problem that you will get. So let's start. So there would be two parts for this question. Part 1 would be that we will first try to write it in this form, and then we will solve it. So step 1, you can see your a is 8, your b is negative 96, and your c is 279. Since my a is not equal to 1, I have to make it 1. And how I can do that? I can take out 8 outside, and hence I'll be left with 8x square minus 12x plus 279. Mind this thing that you are just factorizing a and b, the term containing a and b, and you are not touching your constant term at all. Next, here you can see this is again like a quadratic, which is inside the bracket x square minus 12x. Here your a is 1 and your b is negative 12. So we will have our b and we will add and subtract its square. So we will start. We have got x square minus 12x, then I will have plus minus 12 over 2 whole square minus 12 over 2 whole square, bracket close, plus 279. Let's simplify it further. We will have x square minus 12x minus 12 over 2 is negative 6. Negative 6x square is positive 36. So I will have positive 36 here. Again I will have positive 36, but I have a negative sign right over here. So that will give me negative 36 plus 279. Now have a look at this one. This is nothing but x minus 6 whole square. So you can rewrite it as y is equal to 8 x minus 6 whole square minus 36 plus 279. Y is equal to, we will expand the bracket, 8 times x minus 6 whole square minus 288 plus 279. Let's simplify it one more time. We will have 8 times x minus 6 whole square minus 9. So part 1 done. Now we can proceed with the rewarding step of solving it. In order to solve it, we have to equate it to 0. So this quadratic function will be equated to 0. Then we will have 8 times x minus 6 whole square is equal to 9. And then I can move the 8 to the other side. So 8 minus 6 whole square, no, it is 8 minus 6. This will give me x minus 6 whole square is equal to 9 over 8. Let's take the square root. X minus 6 is equal to plus minus root under 9 over 8. That means x is equal to 6 plus minus root under 9 over 8. You can use your calculator and get the answer in decimal. I'm just leaving it in this form. Let's move ahead to the exam style questions now. Exam style question 1. So this question came in IGCSE Pearson Further Pure Maths course. So this is our exam style question 1. So we have got the function fx is equal to 3x square minus 9x plus 5. Given that fx can be written in the form a times x minus b square plus c, where a, b and c are constant, find the value of a, the value of b and the value of c. So part 1, here we are supposed to just rewrite it in the vertex form. So my function that I have got is y is equal to 3x square minus 9x plus 5. Let's rewrite it. So clearly my a is not equal to 1. So I will factorize these two terms first. So I will have 3 out. I will have x square minus 3 bracket close plus 5, and I will try to do the completing of a square right here. So it implies that y is equal to 3 times x square minus 3x. So here I have got minus 3. I will add its square, half of its square, and I will also subtract half of its square from it in order to complete the square. This will give me y is equal to 3 times x square minus 3x plus 1.5 square minus 1.5 square plus 5. Now this I have got, this can be rewritten as x minus 1.5 whole square. So this will give us y equal to 3x minus 1.5 whole square minus 1.5 square plus 5. Let's continue. It implies that y is equal to, I can expand the bracket, so 3 times x minus 1.5 square minus, so 1.5 square is 2.25 and 2.25 times 3 will give me 6.75, and outside of the bracket I had 5, so plus 5. Let's simplify it further. Y is equal to 3 times x minus 1.5 square minus 1.75. Hence my a is equal to 3. In this case my b is 1.5 and my c is negative 1.75. So I did my part A. Let's try doing our part B. From part A we got the answer for part A was y is equal to 3 times x minus 1.5 square minus 1.75. Let's try doing the part B. In the part B we are asked, hence write down the minimum value of fx and the value of x at which this minimum occurs. I'm going to plot the graph in order to demonstrate what the minimum value will look like. Here you can see I have got a, which is my the coefficient of x square is positive, so I will have a concave up parabola, and in this concave up parabola the coordinate of the vertex are going to be 1.5 and negative 1.75. So the minimum value of the function over here is negative 1.75, the y value. And at what value of x this y value is coming up? It's coming at 1.5. So hence we have answered the minimum value of fx was negative 1.75 and the value of x at which this minimum occurs is 1.5. We got our 2 marks. Let's move ahead to the another exam style question. This is our second exam style question from edXL Pearson Further Pure Maths. So this is our exam style question 2. So the question is fx is equal to 2x square minus 12x plus 5. Given that fx can be rewritten in the form of fx is equal to a times x plus b whole square plus c, where a, b and c are integers, find the value of a, the value of b and the value of c. So in other words, we have to rewrite it in the vertex form. So let's start. So we have got y is equal to 2x square minus 12x plus 5. You can see the coefficient of x square is not 1, so we need to factorize it and make it 1. So I will start with 2 outside x square minus 6x, and I will keep my constant term as it is. I am not factorizing my constant term. After that I will go ahead 2 times x square minus 6x. So minus 6x is here. I have to half it and then add its square and subtract its square. So I will have plus minus 6 over 2 whole square minus 6 over 2 whole square plus 5. That will give us y is equal to x square minus 6x plus 9 minus 9 bracket close plus 5. This quantity over here is nothing but x minus 3 whole square. We will get y is equal to 2 times x minus 3 whole square minus 9 bracket close plus 5. Let's open the bracket or expand the bracket. We will have 2 times x minus 3 whole square minus 18 plus 5. It implies that y is equal to 2 times x minus 3 whole square minus 13. So that's what we have got, and this is my vertex form. You can see if I try to plot this graph, since the coefficient of x square is positive, I will have a concave of parabola. The coordinates of vertex are going to be 3 comma negative 13, and here we are supposed to rewrite it as a times x plus b whole square plus c. Now the exam board is notorious for writing questions like this, and here they are checking your understanding whether you can follow the instructions properly. So comparing our equation, our vertex form, with the given form in which they want our answer, we can say a is equal to 2, we can say our b is equal to negative 3, and our c is equal to negative 13. So we have to write it in this form so that we can get our all full 3 marks. Now, this wasn't the difficult part. The difficult part is here. This is the most challenging part that many students found while doing this paper really difficult. So let's discuss the second part. So the second part of the question says we are supposed to hence find the set of values of x for which fx minus 37 is greater than 0. Now from part A, our answer came out to be, we have got our fx as, or y as, 2 times x minus 3 whole square minus 13. I will rewrite it as fx is equal to 2 times x minus 3 minus 13. So let's do our part B. So for part B, I need to replace fx by 2 times x minus 3 whole square minus 13, and then I will subtract 37 from it, and it should be greater than 0. So let's solve this inequality. So 2 times x minus 3 whole square minus 50 should be greater than 0. Now this question will also help you in understanding quadratic inequalities. So here I can rewrite it as, it implies that 2 times x minus 3 whole square is greater than 50. Now I can divide both sides by 2. That will give me x minus 3 whole square is greater than 25. Now, whenever you have equal to, it is easier. You can just say, okay, I can take a square root of both sides, and I will say the other side is plus minus a square root of 25. But since you have inequality over here, I recommend you use the modulus. So I will take the square root, and when I will take the square root, I will write modulus of x minus 3 is greater than a square root of 25, which is 5. Here I need not to write plus minus 5 because this modulus sign will take care of it. So modulus means the distance on the x-axis from the origin. So if I draw my origin here, there are 2 points for which the distance can be equal to 5, which is positive 5 and negative 5. And I want the distance to be greater than 5, so it means I should go in this region or I should go in this region. So that means either x minus 3 is less than negative 5 or x minus 3 is greater than 5. If I will take this case, it implies that x is less than negative 2 or x is greater than 8. So this is my answer. I can write x is an element of negative infinity to negative 2 union 8 to positive infinity. So that's my answer for the inequality, and that's how you will do it. So let's go ahead and do a quick recapitulation of whatever we have learned today. So if you have y is equal to x square plus bx plus c, in order to write it quickly in the vertex form or completing the square, what you can do, you can just half your b, you can write it as x plus b over 2 whole square plus c, and then you subtract b over 2 whole square from it. Now depending upon the sign of your b, this plus or minus will be adjusted accordingly. So I believe this video was helpful in understanding completing the square and how we can use it for solving quadratic equations. If you have any further questions, please post in the comments and don't miss to watch the other video from quadratic series. Thank you so much.